really old.
All right, so we're going to take a look at day 8 today, which is sigma or summation notation and series. So we're going to learn this new term, what a series is, and how it relates to what we've been doing. So let's do a quick review, warm up. Consider the sequence, write the recursive formula, the explicit formula, find a sub 12, and find a sub n. Find n if a sub n is 47. All right, so a lot of information here. This is a good review. So first thing we have to figure out, is it arithmetic? Is it geometric? What do we got? If you don't know, take one number, subtract the one before, or divide and see what's happening every time. So if we take a look at this one, you can see it's going up by 3. This is arithmetic. Here's the recursive formula. The first term is 2. To find any term after that, we take the term before it, and we're going to add 3 to that. Let's write the recursive formula. The explicit formula. So to do that, if it's going up by 3 every time, that's the slope. So we have y equals 3x. And the y-intercept, remember this is term 1, term 2, 3, 4, and 5. So to find the y-intercept, we have to find term 0. So instead of adding 3 every time, we'll subtract 3. 2 minus 3 is negative 1. So here's your formula, the explicit formula. How are x and y related? Y equals 3x minus 1. Let's use that to find a sub 12. So there's two ways. You could type it in your calculator and hit enter until you get to the 12th term, or we can use the explicit formula, y equals 3 times 12 minus 1, and so we'd have y equals 35. Okay, again, the other way to do it on your calculators, you could hit 2 and then enter, and then plus 3. Was that our slope? Yeah, it was. And then, so that was the first term. Here's the second, third, fourth, fifth, sixth, seventh, eighth, 9th, 10th, 11th, 12th, and then you get it that way as well. So there's recursively in your calculator. Here's explicitly using the explicit equation. Find n if a sub n is 47. So again, you could just use your calculator. We know that this is the 12th term. So here's the 13th, 14th, 15th, 16th. So it's the 16th term. Or you can use the explicit formula, and this is saying, all right, if the y value is 47, can you solve? So I'm going to add 1 to each side. We got 48 equals 3x, divide by 3. And so here you get n. I should use n instead of x, but n is 16. So this is the 16th term, would give us 47 for an answer. Okay, next. Get rid of that. Let's try the next one. Consider this sequence. This one is geometric. We can see it's being multiplied by 2 every time. So the recursive formula, the first term is 3. To find any value of n, we take the 1 before it and we multiply by 2. Here's the explicit formula. Two ways to write this one. The first way is the first term, 3, and it's doubled every time, but then it's to the n minus 1 power. So that is if you use the first term. If you use the 0 term, though, the other way you can write this is you can go backwards 1, so you can divide by 2 to go backwards 1, so that's 1.5. So you could also say 1.5. Oops. And then this would be to the n power. So there's 2 ways to do this. So if you jump ahead a power, if you really take this as your first term, this has to be n minus 1. So you can use either one. I prefer either one. You can use whatever you prefer. So using either one, can you find a sub 11? Okay, so again, you can do this in your calculator. So here's how you do it in your calculator. We type in the first term, which is 3, hit enter. We do that answer times 2 every time, and so that was the first term. Second, third, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th. So there's one way to get the 11th term, just hitting enter. The other way to do that is you could use your explicit formula. So I'll just use the first one. So 3 times 2 to the 11 minus 1 power. So that's 3 times 2 to the 10th power. We should get the same thing. So let's check and see if I hit enter the right amount of times. So 3 times 2 to the 10th power. And you get the same thing. All right, try the next one. Find what term is it so that the answer is 384. Again, you could keep hitting enter and figure that out. I think we actually went past that. But we could also solve it algebraically. So I'll solve this one algebraically. So we have 384 equals 3 times 2 to the n minus 1 power. We could log this. We could divide each side by 3. Let's see if it's still in our calculator. There it is, the 384, but I forgot what I counted to get that. So I'll type this in. So 384 divided by 3 gives us 128. Okay, so if I'm showing my work here, we have 128 equals 2 to the n minus 1 power. Remember, you can log this. Log base 2 of 128 equals n minus 1. So take this answer and then add 1 to that to get n. All right, so let's do that. Log base 2 of 128. Hit enter, and we'll add 1 to that. So that was the 8th term. The 8th term gave us 384. So we say n equals 8, the 8th term. All right, sorry. Here it is. N equals 8, the 8th term. Okay, so there's a quick review. Now we start the new stuff. And so here's the new stuff. It says we will now start focusing on finding the sum of sequences. All right, the sum of sequences is called a series. Okay, so when you add up these sums, it's called a series. One way of representing the series is using summation notation or series, what do I call it, sigma notation. So sigma notation, because this symbol that we use is sigma in Greek letters, or we can call it summation notation because we're adding things up. So summation notation or sigma notation is adding things up. All right, so here's that weird Greek symbol sigma, which means add things up. Tells you where to start. Start at the first term, go to the 6th term. We use a rule to calculate. And so I'm going to show you how to do that. And then we're going to break it down even further. So here it is. Write the following as a sum of the terms. So this is finding a series. And then find the sum. All right, so here's what it means. Start at the first term. Go to the 5th term using that rule. Okay, here's what it looks like. 3 times 1 minus 1. There's the first term. Plus 3 times 2 minus 1. Oh, I wrote really big. Plus, I should have written smaller. 3 times 3 minus 1. Plus 3 times 4 minus 1 plus 3 times 5 minus 1. Okay, so again, we use this rule for 5 terms because it goes from the first to the 5th term. And we will get those answers and we will add them together. Okay, so let's do that. Let's use pink. Okay, so 3 minus 1 is 2, so that's 2. 3 times 2 is 6 minus 1 is 5. 3 times 3 minus 1 is 9 minus 1 is 8. You can see this is just a slope of 3. We're just adding 3 every time. So 8 plus 3 is 11. This will be 11. 11 plus 3 is 14. All right, so here are all the actual sums. So we're going to add up 2 plus 5 plus 8 plus 11 plus 14. And that will be our answer. So let me add them up for you. 2 plus 5 plus 8 plus 11 plus 14. We get 40. 40 is the answer. Okay, let's try the next one. Add up the 4th term to the 7th term. The rule is just n, the term number. This one's easy. It's just 4 plus 5 plus 6 plus 7. Okay, so we go from the 4th to the 7th term in our list. We add those together, and we will get 22. Let's try the next one. All right, 4 terms. The 1st to the 4th term, we're going to add them up. So when we plug in, here's what it looks like. 3 times 2, keep that the same, but to the 1 minus 1 power, plus 3 times 2 to the 2 minus 1 power, plus 3 times 3 to the 3 minus 1 power, plus 3, oh, there shouldn't be a 3 here, I'm sorry, there should always be a 2, plus 3 times 2 to the 4 minus 1 power. Okay, so essentially, this is 3 times 2 to the 0, plus 3 times 2 to the 1st, plus 3 times 2 to the 2nd, plus 3 times 2 to the 3rd. All right, I know that 2 to the 0 is 1, so this is just 3. I know that this is 3 times 2, which is 6. I know that this is 2 times, so I have to do the exponents first. 2 squared is 4. 4 times 3 is 12. Plus 2 to the 3rd is 8. 8 times 3 is 24. So we're going to add all these up. 3 plus 6 plus 12 plus 24, and I believe the answer is 46. So again, to reiterate, Here's the anatomy. N is this is the starting term. This is the last term. We put our explicit formula here, and there's two types. If it's arithmetic, it's y equals mx plus b. If it's exponential, geometric, exponential, again, you can choose which one you like to do. You want to start the 0 term or the 1 term, but you put in your explicit form for your geometric series. All right, so let's do an example of each, and then we're going to practice this. So here it is, arithmetic summation. Again, here's your first term, second, third, fourth, fifth, sixth, seventh. So this says add them up from the first term to the 7th term. We need the rule, we need the slope and the y-intercept. You can see the slope. This is going up by 3 every time. The y-intercept would be if you go backwards, 3. 2 minus 3 is -1. So our equation for this would be -1 plus 3x. Instead of x, I'll put an n, so -1 plus 3n. Here's the summation notation. That means this. Add them all up. Okay, let's do this one. Okay, so again, here's our first term, second, third, fourth. Oh, but we don't know what term this is. So let's figure out the explicit form. Y equals mx plus b. Our slope here, you can see we're adding 7 each time. We have to go back 7. So 1 minus 7, or sorry, -6 minus 7 is -13. So our equation is -13 plus 7x. And we want to figure out what term gives us 71 for an answer. So 71 equals -13 plus 7x. We're going to add 13 to each side. So we get 84 equals 7x divided by 7. 84 divided by 7 is 12. So the 12th term, so x equals 12. All right, so this is the 12th term right here. So now we write sigma notation. I'm going to just change this slightly. All right, so sigma notation is that we're looking E, and we start at the first term and we go to the 12th term. Here's the rule with n. So here's your y-intercept and then your slope. Okay, so there's sigma notation. Okay, let's try that. If it's geometric, it looks slightly different. The explicit formula is different. Again, we have our first term, second, third, fourth. We have 5 terms here. So here it is. Sorry about that 5, it looks terrible. So we start at the first term, we go to the 5th term. And we start with our starting value, which is 8. And these numbers cut in half every time. And this will be to the n-1 power. The other way you could write this is, again, we start at the first term, go to the 5th. But if you want to start the 0 term, so go backwards 1. So instead of dividing by 2, you multiply by 2, and that would be 16. And then you could start at the n power right here. So both of these are correct. Okay, last one, and then I have to practice this. All right, so again, we have our first term, second term, third term. Uh-oh, what term do we have here? Let's write the rule. So here we start, 3 is the first term. It's doubling every time. So here's the explicit rule, but we want to know what makes this 192. So if you remember from last chapter, we would divide this by 3. 192 divided by 3 is 64. So you have 64 equals 2 to the n-1 power. We could log this. All right, so we have log base 2 of 64 equals n-1. Put that in your calculator, but then add 1 to that. And so here our term is 7. Okay, so this goes up to the 7th term. All right, let's write the explicit formula for this. Okay, so again, I'll just write it down here. I apologize. Okay, write it in purple. Okay, so here's sigma notation. And this starts at the first term, goes to the 7th term, and we put the explicit rule here. Or if you choose to and don't want the n-1 thingy, you could also write this like this. So start the first term, go to the 7th. Oh, but go backwards, so again we know this is going up by 2, and instead of multiplying by 2 every time, we divide by 2. 3 divided by 2 is 1.5, so you could also put it this way. Eek. Okay, so here are the 2 explicit formulas that work. They both mean the same thing. Okay, so for your assignment, try writing summation notation. We will review.